Welcome to Advanced Java Programming at Portland State University. In this screencast, we'll continue our discussion of Google Web Toolkit, GWT, a framework for building rich internet applications in Java. So previously, in our introduction to GWT, we learned about the GWT framework itself, how it's used for building rich internet applications. The vast majority of the code is written in Java. There is a little bit of HTML and CSS in there. But the thing that makes GWT unique is that the Java code is compiled down into JavaScript, which is then deployed along into a Java web container, just like any old Java web application would be. We saw how Maven helps you build your application, makes things a little bit more straightforward and simple. And we saw how you can work with GWT in one of two modes. During development, you work in something called hosted mode or development mode, in which your application is actually run entirely in Java, and a special web browser plugin allows you to interact with it. And since it is run entirely in Java, you can use your Java debugger to attach to it and debug both the client and server-side functionality. Then when you want to deploy it, you run in something called web mode, which will compile your client-side code from Java to JavaScript, bundle everything up into a WAR file that can then be deployed to a web container. We'll continue our discussion and dive into some of the details of all the how you do the UI programming in GWT. There is a class hierarchy of widgets. These are classes that represent various visual components that can appear on a web page in a GWT application. There is a package called COM Google GWT User Client UI, which contains all these classes for modeling user interface widgets. So at the root is an object called UI object, which has some amount of shared functionality that all these other classes have. Menu items and menu separators are for things that are for referencing and describing menus. And then you've got widgets. The vast majority of your widgets are descended from widgets. So everything from static text like labels or HTML to menu bars, images, widgets that are subclasses of focus widget, get the keyboard or mouse focus, things like list box and buttons, rich text areas, text boxes and password text boxes, and then there's a hierarchy of buttons. And we'll see examples of these shortly. So a label is basically a plain piece of text that usually describes some other widget, what it is or what it does. There's a subclass of label called HTML, which not only has plain text but also can contain markup to be rendered. And you can say whether or not you want words to be wrapped in your label. Here is an example of how to use label. In all of my examples, they subclass a class called example, which has some common code. You can go look at the source. It basically handles a little bit of layout, and it's a container in which widgets can reside. They all have names. So the label example is constructed first by invoking a superconstructor with the name of the example. And it's going to add several things. It's going to add a label widget to itself, an HTML widget, which has a little bit of markup. And then it's going to show how word wrap can be either true or false. Now let's go back to our browser. And we'll see here are some of our examples. So when that code is compiled, this is a label. It gets rendered here, just plain old HTML text here. Here's a label with with italics on it. And there are two with word wrap. A list box is basically a list of strings, and you can add strings to a list box with add item, and you can configure whether or not it is a drop-down or a multi-select. And then when you want to find out what the user has selected, you can invoke methods on it such as getSelectedItem and getSelectedIndex. And you can also specify how many of the items in the list are visible at any given time. So working with this widget looks something like this. Create my new list box, add some items to it. I'm going to add the box itself to the example. This is going to be a multi-select with those three items in it. I'm going to add that. What we get are these two list boxes. You get a drop down here to choose from, and then you get a multi-select here. A text box is for entering a single line of text. You can say whether or not, well, you can specify the number of characters that are visible and then the maximum length. And then when you want to find out what the user entered, you can call the getText method on the object. So here's an example of a text box. Here we create an empty one with no text in it. Its visible length will be 15, its max length will be 10. We can have text boxes that are read-only. And then there's a subclass of text box called password text box that you can add there. Here are the text boxes. So I can start. I've hit the maximum length. This guy is read-only, and this guy is a password. Text area allows multiple lines of text to be input, and you can set how wide and how high, how tall the text area is. Rich text area allows not just plain old text to be edited, but also allows for well, rich text, HTML, essentially, with some amount of markup. And so the content is accessed instead of just getting text. You can get the HTML, or you can set the HTML there. There are a number of options and configurations in this API. I won't go into too many details, but you can configure things like what the background color and foreground color are, what text is bold, italics, etc., etc. You can also use what's called the extended formatter to insert horizontal rules, images, ordered lists, everything like that inside your text area. The rich text area, not every feature is supported on every browser, although these days it probably is. But before you want to look before you leap, the browser object, or sorry, the rich text area object will tell you whether or not a particular formatting feature, such as horizontal rule or ordered list, is supported well on that browser. So here's an example of a text area. I can have multiple lines. Notice you automatically get a scroll bar. Here's a rich text area where you can have bold text and you can have various kinds. The rich text editor itself doesn't have widgets for editing. You could add your own widgets for for saying, hey, click here to make the selected text bold. Here's an example of how that works. Pretty straightforward API. You create the text area, you set how big it is. Same thing with the rich text area. Here I just have markup that's interpreted inside the rich text area. Okay, buttons. There are several kinds of buttons in the GWT API. There's a plain old button, which is just clicking it, performing some action. It's got a string in the middle of it. You can have a checkbox. You can also have a push button, which can be either in an up or down state. And you can configure the way the push button looks to have it, I don't know, appear in different colors or have a different image or whatever, depending on what state it's in. So whether it's up, down, when you hover over it, different things can happen. And you can also determine whether or not a push button is down by calling the isDown method. Also something called a toggle button, which is like a push button, but it stays in the down state when clicked. So here it's sort of more of an on or off as opposed to an up or down. Here's using the API. Create a new button object, you give it a label. You can set whether or not the button is enabled. Checkbox, you can set whether or not it's checked. And a push button, which has different, which may have different labels depending on whether or not it's clicked. And similarly, a toggle button may have different labels depending on whether or not it's up or down. Here's a disable button. Here's a checkbox. Here is a push button, and here's a toggle button. Notice that I'm using the default style for all of these. So this isn't the prettiest looking UI in the world. For these examples, I didn't want to invest a lot in making it look really nice. It's more important for me that you guys understand the what these widgets actually look like. There's also a class called window. It's not really a widget. You don't put a window inside something else. Instead, the window represents, well, like the entire browser itself. And it allows you to do things that are sort of top-level browser things. So if you are familiar with doing JavaScript programming within a browser, you know that there are methods like alert and prompt and confirm. Well, these are exposed in GWT versus the alert, confirm, and prompt methods on the window class. It also allows you, this is where you would register things like resize handler and close handler, which would receive events that are triggered when you, attempt to close your browser or when you resize the browser. You can also access the print functionality of the browser by calling the print method, and then you can set the title, which is the text that appears at the top of the browser or at the top of the browser tab or in the browser tab, or status, which is that bar down below. Okay, so widgets themselves are visual elements that you see, and there's a special kind of a widget called containers. The whole idea is that these are widgets that are responsible for laying out other widgets. There are different implementations of containers that provide different, algorithms for laying things out. And there's a big old class hierarchy here, and we'll look at some of these classes in more detail now. Okay, horizontal panel and vertical panel are two of the more simple types of panels, types of containers that basically lay out the widgets they contain in either a single column or a single row. So here I have an example of horizontal panel and vertical panel. I add 3 buttons to a horizontal panel, A, B, C, and 3 labels to a vertical panel, 1, 2, 3. And when I run it, here I have ABC in a single row and 1, 2, 3 in a single column. Dock panel has 5 compartments for its components: the north, south, east, west, and center. And so when you add a widget to a dock panel, you specify what region, what compartment it goes into. So here I create a new dock panel, and I add north, south, east, west, and center buttons with the labels north, south, west, east, and center to the appropriate locations. Right, so there are these constants in dock panel that specify which compartment to put it into. Right, north, west, center, east, south. Deck panel contains multiple widgets, but only one of them is visible at a time. It's like, imagine a deck of cards. And so you're looking at the deck of cards. Only one card is visible at a time, but you can switch between them. The way you switch between them is that by their index. And so each widget in a deck panel is referenced by its index. I won't go into the details of how all this works. I'll just show you the result in deck panel. So up here I have a list box that is configured to be a drop-down, and below it I have a deck panel which contains a number of buttons with labels 1, 2, 3, and 4, and I have this configured such that when I select a given item in the list, it reveals the widget in the deck panel at that given index, etc. Stack panel stacks widgets vertically in a single column, but only shows one of them at a time, and each widget has a label associated with it. So here I have a stack panel. I'm going to put a button with the label of the button is 1, and the label for the stack panel is also 1, 2, 3, and 4. And we look at the stack panel. This is what it looks like. The label is 1 and the widget is 1. So when I click down on 3, it reveals the 1 and 3 and hides the 1 and 1. For those of you who use Microsoft Outlook for email, this is sort of the way things look over on the left side. That was sort of the inspiration, if you will, for this widget. A tab panel is another container that contains multiple widgets, but only shows one of them at a time. But this is, tabs. So you see the labels for all the tabs up top, but you only see the contents of a given tab at a time. Here again, you add a widget and then also give it a label. Okay, and let's look at an example of a tab panel. So you can see up here at the top we have the 4 labels 1, 2, 3, 4, and as I switch between tabs, a different button down here is displayed. So you've probably noticed that while the widgets display, you really can't do anything with them, right? You go to click on a button and nothing happens. Well, here's how we make things happen in a user interface. So when a user interacts with a widget, when they click a button, when they type some text into a text box, when they drag something on the screen, an event is generated. An event is basically an object that says, hey, something happened, the user did something. Events are sent to objects called handlers that are registered on the widget on which the user acts. So you have a button and you register like an on-click handler to handle clicks. So handlers are implemented as an interface, that should have an E on it, an interface containing one method that handles an event. Notice that if you're looking at older GWT code, there were things called listeners. It was replaced with things called handlers that are a little bit more performant. An event object contains the relevant information about the event. So maybe a position on when where something was moved to, a new size, the letter that was typed when the user types something into a text field, something like that. And handlers are often implemented using anonymous inner classes. And this is really, a primary use case for anonymous inner classes. You have an implementation of one of these handler events that only does one thing and does one thing in a very specific context. So for instance, the button handler on a particular button is probably unique to that button. There's no reason to create this class multiple times. That functionality is only going to be used once. So you use an anonymous inner class. If you are incredibly paranoid about performance, maybe you'd want to handle multiple events, events for multiple widgets in a single class. That's certainly an option, but one of the things that GWT has gotten better and better about is efficiently representing these event handlers. So even though in like your Java code you might be creating instances of anonymous inner classes every time, it's really at the end of the day not a significant performance improvement unless your tools and your profiler really tell you that that's creating a lot of overhead. So as you can imagine, there are a whole bunch of different kinds of events, and every event has an event handler. And so there's also an interface called, the so-called has interfaces that are implemented by widgets that generate the event. So there's an interface called has click handlers that is implemented by everything that can handle a mouse click. So all focus widgets, so all the buttons, image, label, text widgets, they all implement this has click interface. Has click handlers interface. So has click handlers has methods like add click event handler and things like that. And the add methods return an object called a handler registration that has the remove handler method. So if you want to then remove a handler from a widget, you would do it through this handler registration object. And all the events, all the objects that are events, are subclasses of a class called GWT event. GWT event has a method called getSource, which is the widget that fired the event. And then subclasses, the individual events, add some more state. So for instance, a resize event gives you a height and a width that is the new resize. That is the new resized size. Okay, here's an example. What this simple program does is it registers a click handler on a button to pop up an alert dialog when the button is clicked. So what we need to do besides importing a bunch of classes, well, here's another example. We add a button, the text on the button is click me, and then we add a click handler using one of these anonymous inner classes, new click handler, on click, it takes a click event object, and it calls window.alert. This is that static method that throws up a JavaScript alert saying I was clicked. So let's go see an example of that. Events. Here's the button click me. When I click that, sure enough, it throws up a JavaScript alert saying, hey, I was clicked. A dialog box is a is a window of sorts that is shown in response to some action. So you can configure dialog boxes to, for instance, be automatically hidden when the user clicks outside it. You can make a dialog box modal, meaning that the user cannot interact with the rest of the UI while that dialog is displayed. We can also configure the title of the dialog box, then also the contents of the dialog box. Here is part of a larger example called dialog box example, and this is sort of the guts of that. It's a method called create dialog box with some configuration. So it's going to create a new dialog box object and configure whether or not it's auto hidden or whether it's modal. It'll set the text, so the title of the dialog box, to auto hide dialog box. And then inside that dialog box, we're going to create a dock panel. Remember, that's the one with the north, south, east, west. We're going to put a label in it, and we're also going to add a button to it that when the button is clicked, it's going to hide the dialog box. I'm going to put that in the south, and I believe the label goes in the north. So we're going to tell the dialog box that it's that the panel should go inside the dialog box, and then we're going to display the dialog box in the center of the screen. Simply return it. Here's our example of the dialog box. When I click this button, it's going to show a dialog box that is auto hide, meaning that if I click outside it, it'll automatically go away. I can also click the close button to make it go away. And if I get a modal dialog box, it means that I can't click outside it. I can move it around, but the only way I can dismiss it is by closing it. Okay, so there are a whole bunch of other types of events and event handlers. I'll kind of go through the catalog here quickly. This is all in the GWT API documentation that you can easily find online. So there is there's an event called a change event, which is handled by a change handler. This is when the contents of a widget changes. So things like list box, text widget, text boxes, things like that, they all get these change events when things inside them change. Focus handlers on focus method is invoked when some widget gets keyboard focus, meaning that's been clicked on or tabbed to. There's also a blur handler that gets invoked when a widget loses keyboard focus. For dealing with keyboard events, you've got key up events, key down handler, key pressed handler, and things like that. And the way you get the character that was typed is by calling the get car code method. Note that key up and key down event also have the get native key code, which represents keys like home and delete. And I've got an example of that that I'll show you shortly. Also, there are a couple kinds of events that are fired in response to working with the mouse on a widget. So, clicking the mouse, moving the mouse wheel, etc., etc. Well, all of the focus panels and then the widgets that get mouse focus can receive all of these events. Mouse wheel event is kind of interesting. You can get the velocity of the wheel scrolling, and this is how you can determine whether or not it's how fast you should display some action. Let's take a look at some of these complex events. So let's see here. I've got, if I click on this guy has keyboard focus. If I type letters, it'll say. If I hold down Shift, it'll tell me. And if I try to do things like page down, end, home, delete, oops, also delete it in the browser. Let's go forward one more time, etc., etc. I can also scroll the mouse wheel up and down. Notice the event is also going to the browser too. And let's see if I click and drag. I guess I don't have, well, I got focus, and then here again, I can click there. Okay, so now we've seen really the pieces parts of a GWT application, right? We've seen this catalog of widgets, a whole bunch of containers that will lay out the widgets in relative position, and we've seen how to handle mouse events. So when you think of building a GWT application, there are basically three steps. The first one is create and configure your widgets. So create all of the objects, sort of wire them together, adding them to containers. Arrange the widgets in a panel, here again with layouts, and then register event handlers to handle all of the user interaction. Now that we've seen how to develop code for the client side, again with the widgets and the layouts, the event handling, now let's talk about how the client communicates with the server. So remember that I mentioned that there's this thing called AJAX that uses this object in the browser called the XHR, the XML HTTP request object, for making calls between the client and the server without reloading the pages, without reloading the page. In order to make a call from the client to the server, you need to use that object, and then you need to use that JavaScript object, and then you need to send some data back and forth, a request and a response. And GWT has a really nice abstraction on top of all of this called GWT RPC, GWT Remote Procedure Calls. So the whole idea is that the server provides essentially something that looks like a Java object that is remote, meaning that in the client you have an interface on which you can invoke methods that essentially gets executed on the server. And GWT takes care of all of the marshalling and unmarshalling of data in between the client and the server. If you've worked with a remote method invocation before, this might seem familiar to you. If you haven't, well, don't worry if it's a little wacky, because this is distributed computing. You've got two processes talking to each other, and you've got this nice abstraction on top of it, so you don't need to know all the low-level details. But you still need to be aware that there's something going on there. The whole idea is that GWT RPC provides this concept of a service. And a services contract is specified by an interface that extends GWT's remote service interface. And this is what one of those services look like. It performs integer division. It is an interface called division service that extends remote service and has one method divide that takes two arguments, an int dividend, an int divisor, and returns an int quotient. This remote service, you also need to tell GWT kind of the path, or the name, if you will, of the service. It's going to be called division, and the way you specify this is with this @remote service relative path annotation. Underneath the covers, this gets turned into a URL that the client then calls, but that's not really something that needs to be at the top of your mind. The service is shared between both the client and the server, and so the interface resides inside the client package. On the server side, the service is implemented by a class, well, it's in the server package, and it extends remote service servlet. Yes, this is actually a servlet, a plain old Java servlet. Well, actually, it's a special Java servlet that knows how to handle these GWT RPC requests from the client. So your service impl will extend remote service servlet, and actually if you go and look at the source code for remote service servlet, you'll see that's a Java servlet. It has a special method that basically knows how to interpret the GWT request. Actually, well, we'll talk about what it means in a second. And here what you do is, this is the service that implements the division service. So here you've got, it's a remote service servlet, and since it implements the division service, it has to provide an implementation of the divide method that's declared on division service. And so it is the thing that actually performs the division operation. Because this, service impl is a servlet, you configure it just like you would any other servlet. So you would deploy it in your GWT web application along with everything else. So you would have, division service impl is a servlet called division service, and you want to map it to a URL like /examples/division that corresponds to the name that you gave here in your remote service relative path. So remember how I said remote service servlet is a servlet and does some special stuff? Here's what it does. So when your client invokes this remote method, when it calls the method on the service, it's going to send down some arguments. And so the compiled GWT code, the compiled JavaScript will take the arguments, in this case two ints, encode them in an HTTP request that is made through using that XHR object, and it'll hit the URL that you registered your servlet with. Notice that you don't implement do get or do post like you would in a regular servlet. If you go look at what remote service servlet does for you, it implements get, or do post, whatever it is, it's probably post. It implements do post, and it handles all of the communication protocol. And what it does is it takes this request, and the request, which is essentially this remote method invocation, says a number of things. It has the arguments, but it also has the name of the method that it wants to invoke. The remote service servlet then uses reflection to find this method on the service impl, invoke it, and then return its result or an exception if it's a problem, if an exception occurs, back to the client. As you can imagine, that's a lot of data encoding, a lot of goodly amount of logic, etc., etc. All that is taken care of for you. All you need to do is just implement this method. So we saw that there's a Java interface for the client. There's an implementation for the server, and here's how you actually go and invoke the method in client code. In GWT, all calls from the client to the server are asynchronous, meaning that the call doesn't block when you call it. If it did, your application will behave really bad. You guys are probably too young to remember, but back in the old days of like Windows 3.1 or even some applications today, if you go and click a button and it performs a very expensive operation, maybe needs to read a big file from the disk or go make a request over a slow connection, your UI stops responding, right? I suppose on the Mac you still get the little spinny beach ball or whatever it is when things slow down. That's what happens when you make asynchronous method calls. Like I click the button, I want to go fetch some information from the server, and I'm going to wait until its response. Well, that doesn't make for a pleasant user experience. If you're going to have something that's slow running, you want it to be happening there in the background, and then when the result is ready, have it delivered to the client sort of out of band or asynchronously or when it's ready. The way this is implemented in GWT is that when you make a remote method call, you not only send the parameters to the remote method, but you also register or send an object that implements this async callback interface. And so what the client code works with is a peer to the service interface that is called the async version. So for instance, we had our division service, which took two ints, a dividend and divisor, and returned the quotient. Well, in order to invoke this asynchronously, we have a division service async interface that takes those same arguments, but instead of returning the quotient, it has a void return value, and the return value is delivered to a method on this async callback class. So how do you get one of these things? Well, there's a little bit of magic involved. So there is this class in GWT called all caps GWT, which does some special stuff. As a matter of fact, when the compiler sees that you're calling this class, you're calling a method on this class, it does some special things. Basically, what you do in order to get one of these instances of division service async is that you say GWT create with division service. And what it'll do is it'll look at the division service class, it'll use, let's just pretend it's reflection, and it'll discover from that annotation what the URL should be, and then it creates, here again, sort of a magical implementation of this division service async interface, which will then provide the asynchronous divide method. Here's what the code looks like for actually invoking the division service asynchronously from GWT client code. I'm going to show you a UI that has a couple of text fields, one for the dividend, one for the divisor, and then the quotient is going to be printed in another, printed, whatever. It's going to be, the value of the quotient text field is the value of the quotient. So and there's also a button to perform the division. So when that button is clicked, the program does the following: it gets the text from the dividend field and converts it into an int. Gets the text of the divisor field, converts it to an int. And notice this is integer.parsent. This code right here all gets turned into JavaScript. Integer.parsent is another example of a class in that JRE emulation library that gives you the standard Java API, but in JavaScript, or in a subset of the standard Java API that can be compiled down into to JavaScript. So now it's got the dividend and the divisor, and now it wants to make the remote call. So it went and got its service by calling GWT create, and this is the async service. It's going to call the divide method. It's going to send in the dividend, the divisor, and it's going to register or also send in an async callback method. Async callback has two methods. On failure, which is invoked when an exception is thrown while invoking the async callback, and then on success, when the async callback returns successfully. Now, and then what is onSuccess going to do? Well, onSuccess is the argument to onSuccess is the return value of the two argument divide method. So it's going to be the quotient. It's going to get that integer and set the text of the quotient field accordingly. This example is a little out of date because async callback now has a generic type, which is the type of the object returned. So I think what you'd really want to do is say async callback of int, and now onSuccess would take an int, and you don't need to have this cast anymore. So let's see how this looks in our on our example application. Here's a division service, so let's do 6 divided by 2. When I click equals, this is of course the dividend and the divisor. When I click equals, we're going to get the values of those. We're going to make a remote call off to the server, and it's going to return the value 3. And actually, we should be able to see that in, yep, right here is our call to, we made a post. So Jetty received a post from examples division. Anything here? No. Let's do another one. Let's do 6 divided by 3. Again, you got another one. And anything? No, nothing there. Nothing terribly interesting there. Finally, let's do something that's a little more problematic. 6 divided by 0. What's going to happen? Well, we got an exception. So now we tried to divide by 0. We get a divide by 0 exception, and then what was returned to the client was a status code exception saying, "Hey, I got a 500 while working on the server." Let's see if dev mode. Oh yeah, look at all this stuff. We made a request, and it's a 500, and so it goes and it gives us access to all of the request headers. It isn't terribly interesting. I wonder if you get something here. No, but this definitely says something goes wrong. And was there anything? There wasn't anything spat out there. So anyway, it does give you some stuff. And probably what I would do next, I was relaunch my application in debug mode, attach a debugger, and see that, oh yeah, sure enough, I'm trying to divide by 0. I'm not sure if I have this in the lecture notes, but I also have an example of a GWT timer, which essentially just fires an event, sort of a change event, every number of seconds, every so often, and when it does fire, the event is handled, and I simply update the date in this field here. So this shows not only how dates are formatted, but then also how the timer works. Okay, I think it's a good stopping point for now. As always, thanks for watching the screencast for Advanced Java Programming at Portland State University.